Hi guys, today I'm going to talk to you about digestive enzymes. So this is the first time that you're really going to go into something like this. So if you need to watch the video twice, it might not be a bad idea, but hopefully you can get it the first time. So the page I'm looking at right now is called number 17. And what I want to put here is also, we're going to call this note enzymes. Okay? And enzymes are chemicals that help you to digest your food. Okay, so they break down nutrients. They do a whole bunch of other things. But for us in grade 11, we're going to say enzymes are chemicals which, and I'll say chemically, break down food. Okay, and I'm going to say into their smallest components. Okay, you'll probably find a better definition of that somewhere online, but that's our definition. So enzymes are chemicals which chemically break down food into their smallest components. So an enzyme is a chemical, and what it's going to do is it's going to break down anything that you eat into the chemicals that make it up. Okay, so in other words, when you eat carbohydrates, okay, so when you eat pizza, there are carbohydrates in the pizza. So you've got an enzyme to take the carbs out of the pizza and then to break the carbohydrates down into their smallest components, okay, which would ultimately be glucose, all right? So that's where we're going here. So I'll give you one more example of that, and then I'm going to head into this note. So if we eat, I'm going to say something different, something that starts with a C. Okay, so I'm going to say cheese, okay? And cheese is really a fat product. So the cheese is going to be broken down into fatty acids and glycerol. Okay, so this is going to be fatty acids and glycerol. I'll just go back to the pizza. If you have a pizza and you've got a cheese pizza, then the cheese is going to be broken down into fatty acids and glycerol. And then we can say the crust is going to be broken down ultimately into glucose. Okay, and that's the job of enzymes. So enzymes take your pizza, take all the components and break them down into those nutrients, the building blocks of the nutrients that I taught you about yesterday. Okay, and that's the reason we did nutrients first. So now that you know what your nutrient building blocks are, enzymes are going to make a little bit more sense. Okay, and where do you find these enzymes? In various places, and that's my job today, to tell you where you find them. So the very first place we're going to find, and I could highlight all of this, the very first place we're going to find an enzyme is in your mouth, and it's going to be in your saliva, okay? Where is it made? The salivary glands. That's going to be pretty obvious, so I won't highlight that. What is this enzyme? It is amylase. And so when we refer to this amylase, we refer to salivary amylase, okay? So amylase that's made in the saliva, that's found in the saliva, made in the salivary glands, is referred to as a salivary amylase. And salivary amylase likes a pH of around 7, okay? So salivary amylase likes a pH of around 7.0. Your mouth is pretty much neutral. And so what does amylase do is it takes starch, okay, and it turns it into maltose. So keep that in mind. Starch gets turned into maltose. So your starch is your complex carbohydrate, many sugars. And then what does it do? It breaks it down into the disaccharide named maltose. Okay? So ultimately what it does is it takes a whole bunch of glucose molecules and breaks them down into this. So I'm just going to flip the page over. Sorry guys. Flip this over and just give you a quick little recap on that. Okay, so if this was, and that's an oxygen But this is a whole bunch of glucose molecules together, okay? And now picture this. We'll put one more in here. Picture this times, I don't know, 200, okay? 200 glucose molecules together. What salivary amylase does is it comes in and it breaks those bonds. So salivary amylase, okay, comes in and it severs the bond so that we now have a disaccharide. And this particular disaccharide is going to have 2 glucose molecules. All right, linked together. Okay, we're going to have that. And so this disaccharide is called maltose, and so is this one. So salivary amylase takes a starch and breaks it into maltose, okay? All right, the other thing I want you to know, and I'm just going to go back to this here, I want you to know that enzymes are pH specific. They're also temperature specific, and if you take the 4U course, you're going to find out a lot more about enzymes next year, next semester. But in other words, if you have the wrong pH, if pH refers to acids and bases, right? So if you take an enzyme that is designed to work in a pH of 7 and put it into a pH of 2, the enzyme's not working. It doesn't matter what you do, what you give it, it doesn't matter. So enzymes are pH specific and they are substrate specific. So what does that mean? It means that the enzyme will only work with the specific nutrient that it's supposed to work with, okay? So why am I telling you this also? Because enzymes, if you look at amylase, amylase is going to encounter fats, it's going to encounter proteins. If we put a piece of pizza in our mouth, right? There's protein from the cheese and there's fat from the cheese. It's not going to do anything to the fats and the proteins. Amylase can only work on starch. All right, so it's specific to the substrate, and this is the name of this is the term here that I'm using. The substrate that it works on can only be one type of substrate. It will not even pay any attention to fat or protein. Okay, so that's salivary amylase. That is the only enzyme I'm going to cover in your mouth. So that's something that you need to know. The esophagus oftentimes comes from the old word esophagus that had an O there. Don't worry about that. The O, there are no enzymes in the esophagus, so that's easy. Okay. The stomach has enzymes, and the enzymes in the stomach are contained in something called gastric juice. When you see the term gastric, it refers to the stomach. All right, where is it made? In the pits of the walls of the stomach. So the gastric juice is made in the stomach. Now, one enzyme that's found in the stomach is pepsin. When I see my P enzymes, the enzymes that start with a P, I always think protein. Okay, so that's going to work for you. So what does pepsin digest? Its substrate is proteins. Okay, so pepsin digests proteins. That's what this means, digests proteins. This arrow infers digests. Amylase digests starch. Okay, all right, so the substrate is a protein. What is the product? A polypeptide. So here's a really complicated answer in a very short period of time. Proteins are polypeptides. Do you remember what polypeptides are? Polypeptides are, flipping back here, okay, so a polypeptide, I might not have mentioned this to you, is a string of amino acids. Okay, so many amino acids. So we've got our amino acids. I'm putting only one A in there because I can only fit one A in there. A whole bunch of amino acids together form a polypeptide. I told you that they formed a protein. I lied a little bit. Again, this is going into a little bit more advanced information than you need to know, but it won't hurt you. When the polypeptides are done being linked together with these peptide bonds, okay, when that's done, they curl into different shapes, okay? So they're going to take on a shape. They're not just going to stay in this linear form in most cases. They're going to take on some 3D form where, you know, this amino acid's sticking out at us and this one's going behind. That's when we have a protein. So a polypeptide that's allowed to take on the shape it wants to, that it needs to function, that's called a protein. So if this polypeptide doesn't have its correct shape, it can't work, all right? So proteins are polypeptides that get to take on their shape that they need to function. So a protein is then digested into a polypeptide, which means it's just that linear chain of amino acids, okay? So proteins are digested into polypeptides. Other substances in the stomach, this is not an enzyme, it's an acid, and I'm going to get to it, okay? So today we're just looking at enzymes. All right, the next enzymes we're going to encounter are in the duodenum. Don't worry about the duodenum so much because that lesson's coming. The duodenum is the first section of the small intestine. You're going to know this starting tomorrow, okay? The digestive juice that's secreted is called pancreatic juice, all right? So pancreatic juice. So the duodenum does not make its own enzymes. The pancreas makes the enzymes, okay? And the pancreas makes this. It makes pancreatic juice. And there's a duct that leads, so like a straw that leads from the pancreas into the duodenum. And so the pancreas is going to make something for us and it's going to get secreted into the duodenum. What does the pancreas make in this pancreatic juice? It has amylase, trypsin, lipase, okay, among many other things. These are the ones I'm giving you, okay? So there are about 30 digestive enzymes made in the pancreas. I'm going to give you 3 of them, okay? Amylase, we've seen amylase. Amylase is always going to digest starch, okay? But this is no longer salivary amylase. So this amylase is going to work at a slightly different pH than this amylase up here, okay? Trypsin digests proteins into polypeptides. So proteins they take a lot of work to digest, okay? And lipase digests fats into fatty acids and glycerol. This is going to digest your starch into maltose again, okay? And then there are other digestive juices there. So what I want you to know is amylase continues to work on starch and it works on other enzymes to digest your sugars, all right? And then trypsin works on proteins to make them into polypeptides, which means to untangle their shape. And lipase will cut those fats apart by digesting them into fatty acids and glycerol, the building blocks, all right? Another juice that's secreted but is not an enzyme, okay, is bile, okay? And I'll talk to you more about that tomorrow, but it is in your summary table. And then in the last section of the small intestine, we are going to have these different enzymes at work, okay? And these are the last enzymes you need to worry about. So we have maltase, and it digests maltose, okay? And what is maltose? Maltose is a disaccharide. Okay, remember from the last page that the back of this page, you have this written down. Okay, maltose is a disaccharide, and when we cut maltose, we end up with glucose. Okay, so we're going to have a glucose and another glucose, but they're not linked together anymore. All right? So it digests, final stage of digestion, maltose is going to be digested into glucose. So now we're finally getting to those building blocks. All right, sucrase. Sucrase is also a disaccharide, so it would look similar to this. Okay, so it's a disaccharide, meaning it has 2 sugars, and then it's broken down into glucose and fructose. Okay, this is a monosaccharide, and this is a different monosaccharide. All right, so 1 sugar, monosaccharide. Just because you're not familiar with it doesn't mean it's not a monosaccharide. All right, I just didn't mention it to you because I want to keep things as simple as I can this semester. All right, lactase. When you see lactase, whenever you see ASE, it's always going to indicate an enzyme. All right, so lactase is that enzyme that digests lactose. If you're lactose intolerant, it means you have faulty genes to make this enzyme. Okay, so your enzyme is not working properly. You couldn't make it, or it's not working properly. And so when you have lactose sugar comes from milk. You need lactase to digest it. And what are you digesting it into? This monosaccharide and this monosaccharide. So glucose and galactose is how you say that. So these guys are both monosaccharides. Okay, and that's the ultimate goal of your digestive enzymes that are digesting sugars or starches, is to get them into a monosaccharide. Then digestion is complete. Peptidase digests your polypeptides. So we're still working on polypeptides. Polypeptides are huge strings of amino acids, so it's going to take a lot of work. Peptidase, again, starts with a P. Think when it starts with a P, it digests proteins. Finally, we're going to digest those polypeptides into amino acids. Okay, so we're finally going to get those amino acids on their own. Remember, we're linking amino acids together to make a polypeptide. When the polypeptide takes on its proper structure, then it's then called a protein. When we finally get to that last stage in our ileum where we've got peptidase working on our polypeptides, we're going to get individual amino acids. So all those bonds between amino acids are going to be broken. Okay? And just as an aside, then we're going to use these amino acids to build up human protein. So we're going to take amino acids or proteins from an animal, so you can have your chicken wing. You're going to take that apart into the amino acids that the chicken has provided you with, and then you're going to reassemble these in a different order to make your own protein, to make your own muscle back up. All right, and finally lipase. Lipase is an enzyme, ends in ASE, right? Think lipids, and lipids are fats, okay? And so what we're going to do, we're going to continue to work on those fats from the beginning of the small intestine to the end of the small intestine, and we're going to digest them into fatty acids and glycerol. So those are the building blocks that I told you about a couple days ago, okay? So this is your intro to digestion. You now understand that you have these special chemicals called enzymes. They are specific to what nutrient they're going to work on, and they're specific to the pH that they're going to work on. So I'll just reiterate that one more time. They are pH specific. So in other words, pepsin will work at a pH of 2 in the stomach. If you take pepsin and put it into the small intestine, it does not matter that it knows how to work on proteins. It will not work on proteins. It's only capable of working on proteins in a pH of 2. When we get to this pH of 7, okay, maybe 7.1 or so, then pepsin will turn off completely, okay? And vice versa. If we took peptidase, that's in a pH of 7.1, and we put it in a pH of 2, it's going to shut off, okay? So you've got these enzymes that are pH specific. What is their function? It's to take the nutrients from the food that you eat and break them down into their smallest building blocks.